So hello viewers, my name is Mark and I'm here to present our project SafeBite, which is an AI-powered system that is deployed to tackle a silent health crisis and to make Uganda's informal food spaces a cleaner, healthier and safer place to eat. And of course the people targeted users are the local food vendors, the chapati stores, the owners of those different informal food spaces, the customers seeking to eat in those safe environments, and also the authorities such as KCCA, NEMA, the government organizations, the NGOs in charge of health. So yeah, let's dive into the discussion. So now our objective here is to design an AI-powered system with the help of local sensors and an incentive system with the help of a spatial temporal model to detect, predict, and reduce bad air quality exposures in informal food spaces. So the core problem is the air pollution in those informal food spaces such as the chapati stores, the roadside eateries that expose customers to high levels of carbon dioxide and uh, smoke, where the vendors who work for long hours, they are continuously exposed to this bad air, and for the customers who just eat there around for 10 to 30 minutes, and also the people who just live around those areas such as the residents. So now how the AI is essential here. So now the air quality informal food spaces is actually complex with the factors such as the changing weather, the cooking methods, and crowd density, and manual methods cannot actually capture the dynamic changes of these factors. So that's why the AI comes in it with the use of special temporal models and LSTM models can use to detect, to predict, and also provide operational actions that can help vendors to reduce the exposure of air quality. So what the measurable impacts here? The social impact here is improved respiratory health and awareness amongst vendors and customers, increased adoption of cleaner cooking and ventilation practices. The economic impact here is reduced healthcare costs and creation of cleaner and more attractive dining spaces. The technological impact is development of a scalable AI monitoring framework adaptable to other developing cities. So the users and the stakeholders of our ecosystem. So the main primary users of our systems, like I said in the first slide, are the restaurant owners, small restaurant owners, uh, vendor owners, and also the customers who eat at those various informal food spaces. Then we have the secondary stakeholders like NEMA, KCCA, and the Ministry of Health, and just to provide some funding and also provide public health to ensure that we're providing the right services, and also the ecosystem roles such as the sensor manufacturers, data analysts, and back-end developers. So this just help us in manufacturing multiple sensors that are going to be used at the different informal food spaces, and also analyze the data that is coming in and also ensure that the system is working perfectly and smoothly. Then the governance entities such as Mercury AI Ethics Board that ensure that the system is not violating any ethics. Yeah. So now for the training of our models, we needed data sets with specific type of data, one being sensor data. So this was good from air quality nodes that contained readings of carbon dioxide, carbon monoxide, PM 2.5. These were used for air pollution monitoring, and also geospatial and temporal data. So now this contains GPS locations such as longitude, latitude, and also the various timestamps. And these were used for spatial temporal modeling and trend analysis. And then they also derive metrics such as the itself score. So now these were used for health risk analysis. Then there also behavior data, which contained actions and responses, and it was used for incentive learning. So now the source of our data, one of the sources of our data were one was from AirCo, and then the other one was from Dalton Datasets, which is a group of Indian researchers who researched on indoor air quality. And for the case of the AirCo datasets, they required some cleaning, some pre-processing, such that since AirCo also uses low-cost sensors and some of their values are inconsistent, so it needed some cleaning to produce a consistent data set. And for value mechanism, the data drives real-time air quality feedback, behavior recommendations, and health public insights, creating social value by reducing air pollution exposure and economic value through incentive-driven cleaner businesses. AI system description. So now for our system, we used multiple AI architectures, one of them being the LSTM architecture for time series forecasting. So now for this, we provided a data set, indoor sensor reading data set, and it's supposed to predict the sensor readings for the next 30 minutes. We also have a graph attention network. It's also provided also sensor readings, and it's supposed to predict the different anomalies within the data set. And we also have the graph convolutional network. That one provided timestamps, site location, and it's supposed to produce a PM 2.5 reading of that location. So now, after all these models are processed, a single data set depending on the establishment, all that information then passed on to a itself score model is supposed to predict an itself score basing off the anomalies and the sensor readings, and also suggest recommended actions that the user can use to improve the itself score and also the air quality of the establishment. Now, for the system integration, the system is to be integrated in the itself score web dashboard, mobile app, and also SMS alerts that provide real-time monitoring and automated recommendations, even if there is no internet, uh, using through a cloud host API. Key differentiators. So now what makes us unique is the fact that we have a proprietary local data set, the first real-time air quality data set from organic food species using local sensors. And this is to also add on to what we already have within the country, that is from AirCo. We want to ensure that we have as much information involving about Uganda's air quality as possible to help not only just our air but also future developments to future development that will require our data sets. So hybrid AI framework, this combines temporal transformers, graph neural networks, and context-aware policies for robust spatial temporal modeling. So behavior linked incentives directly ties AI recommendations to actionable improvements, motivating cleaner practices. So now the AI recommendations help the restaurant owners, also the customers, make better decisions to help them improve such that we improve the air quality within the country. Continuous learning, adapting to evolving conditions through live sensor data and user feedback. So now as we get more information, the system continuously learns the new temporal patterns, and it will help make better future predictions that will help in the itself score prediction. Resource constraint optimization. So now this is for the sensors. The sensors are resource constraints that they can be used even within scenarios where there are lack of resources such as electricity, internet, that will, like in case there's no internet, the system will save this information offline, and when the internet is back, it will upload to the server and update the server. If there is no if there's no internet, then to resort to SMS, you deliver information to to the uh, the establishment owners to get continuous feedback from the system and about their establishment. Some inbuilt explainability, transparent scoring, and visualizations to foster trust with the users and regulators. So now channels and distribution. So acquisition channels, one of those shall make people discover the app. More and more people discover the app. Shall go through on-site awareness campaigns at local eateries and markets. We shall use platforms like social media such as WhatsApp, Instagram, Facebook, advertising the app, and also the service through partnerships with NGOs and universities. We should advertise to meet the students and other people across different platforms. So people will be accessing the apps through these various device channels such as mobile apps, and also SMS and USSD for low-tech accessibility. Web dashboard for health inspectors so that they can also monitor the air quality updates across the different informal food spaces. Also to API for third-party platform integration such as City Smart Tools. So the partnerships such as universities for research support and data validation, NGOs promoting public health and clean cooking, digital literacy campaigns to train vendors on how to use the app, and also SMS. to receive the SMSs from the app. Retention tactics. So real-time itself scores and action bar. So now these are ways of engaging the users with real-time information, and then to discontinue to encourage users to continuously use the app if they are getting real-time itself scores, gamified rewards, visibility boost badges, and others are for the managers to encourage them to continuously keep their establishments having clean air. So, because if they do so, then they'll be rewarded with visibility boosts and to promote more users to come to their restaurants. So financial stability is key, and one of the ways our itself squad generates income and sustains operations is through direct revenue models. So a subscription for dashboard access reporting and reporting, license fees for NGO deployments, and pay-per-use APIs for third-party platform integration. Another way is we generate income is through indirect revenue models, data as a service for researchers and policymakers, consulting services for air quality management and interventions, ecosystem partnerships with uh, clean cooking suppliers and health agencies. So then also there are freemium and tier access. So the free basic features for for the small cafeterias, so they can access just basic features. Let's say like itself score, live updates. But if they want like more analytic access, like access the software that does for them analytics, they have to pay an extra fee, a premium fee, so that they can access those advanced features, especially for large organizations that have multiple branches. They would want such information and easily access how the other branches are also performing, and it would require a premium plan in order to access the other restaurant, the other branches information. And also there's value added streams, sponsored research and pilots, white labeled AI dashboards, and tools for partner organizations. So now behind the itself squad system, we need a dedicated multidisciplinary team or of key resources such as human resource, which includes AI engineers, data scientists developing the LSTM grant and policy models, the UI designers refining the itself dashboard and mobile interface, environment scientists, public health experts, ensuring responsible and context-aware AI development. So now this means just to maintain the application, fix bugs, release continuous updates, fix those bugs. And then also there's the technical infrastructure, the cloud storage and compute for the Amazon Web Services and the Google Cloud Platform for sensor data hosting and mobile inference, GPU-powered servers for deep learning training and batch prediction, ML ops tools such as Docker, MLflow, and Kubeflow, enabling automated retraining and continuous deployment. Data infrastructure and integrated data like combining sensors, sensor feeds, aircode datasets, and vendor metadata, API endpoints for real-time ingestion and access by dashboards and partner platforms, annotation, labeling, and validation workflows ensuring data reliability. And there's a resource, financial resources. So we start with the initial seed fundings, and then academic grants for health innovation programs, then potential impact investment channels focused on AI for public health sustainability. So then there are multiple key activities when we look at model lifecycle activities such as collecting and calibrating real-time sensor data from the informal eateries, training and updating the different models in the system so that can improve their predictions and itself scores. So there are product development activities, design user-friendly dashboards and mobile interfaces for vendors and authorities, develop APIs for integration with municipal systems and partner platforms, ensuring engineering for multi-pollutant data and behavior-linked incentives. So then there are also operation activities such as tracking, sensor network performance, data quality, and system uptime. And there's a governance and compliance, conduct bias checks, explainability audits, and privacy compliance. There's customer-focused activities to provide technical support and training for vendors to ensure that they know how to use the system, how to operate it, in case they get any issues, we can back them up and support them and also fix their technical issues. Yeah. Of course, we cannot achieve this alone. We need a couple of partners, such as the technology partners. This would be the we have to fund us with the hardware technology that we can use to install into the different restaurants. The, the cloud providers such as the Amazon Web Services and Google Cloud platforms for scalability and storage analytics. Then also we have the data partners such as, let's say, in our case, be Airco and say the different establishments if to get data from them. Those are the universities for research and support collaboration, NGOs focused on public health and clean cooking. Then we have ethical oversight partners. Now those ones are the National Council of Science and Technology and the Uganda National Bureau of Standards for Responsible Deployment, local ethics boards to review privacy and data collection practices. That is just ensure that we are maintaining the right ethics as we are distributing our services. Then of the distribution partners such as the telecom companies that provide services of that help with their help we provide services of SMS and USDC delivery to the vendors in case they have no network, in case the internet has gone off. Then we have the strategic collaborators, the impact investors, and the social enterprises for grants. Now these grants will be given to the establishments that keep the air clean so that we can encourage them or encourage even fund them to continuously develop their to upgrade their business just for keeping clean air. Cost structure. So now our major costs include sensor deployment, maintenance costs, cloud compute costs, human resource costs, and outreach cost campaigns, as you can see there on the slides. But thanks to our optimized architecture and local partnerships, itself reduces the infrastructure cost by 40% compared to the conventional modern networks. And every dollar invested generates a measurable impact in cleaner air and healthier communities. Governance, ethics, and compliance. So at SafeByte, we believe that AI must be ethical, transparent, and accountable. So our governance model includes an ethics and AI advisory board, compliance with the Uganda's Data and Protection Act, and adherence to the UNESCO AI ethics principles. So we use fairness tools, toolkits like Fairlan and AIF 360 to detect the and mitigate bias, and we document every system decision through the model cards and data statements. So our the human loop ensures that there is no critical decision that happens without human oversight. By this design for scale. So using containerized microservices and modular architecture, we can deploy in new cities quickly from Kampala to Nairobi or even Kigali. So the system automatically retrains using live feedback and localizes communications into local languages. So financially, we reinvest into sensor networks and community incentives, including clean cooking subsidiaries. So our vision is to build a network of smart, breathable food spaces across Africa using AI to drive both sustainability and equity. So our innovation is protected through intellectual property pathways. We hold proprietary rights to our AI food safety and scoring algorithms, low-cost sensor workflows, and adaptive data pipelines optimized for low connectivity environments. So we plan to register the itself Score AI as the SafeByte AI as a trademark, positioning it as a brand synchronized with clean air and public health and also responsible AI innovation. So now this project was made possible by our dedicated three-member team under the guidance of our lecturer, Galango Marvin, and together we are proving that African innovation can lead in AI for public health, not just following global trends, but also defining them. And with SafeByte, we envision a future where technology empowers every vendor, every customer, and even every city to breathe clean and safe air. So thank you for listening to my presentation. I hope you enjoyed it, and I hope we all get on board so that we can make every bite a safe bite.